You know what the fastest, most efficient way to download a piece of content is? Not downloading it at all. My name is Colt McCandless, and when it comes to networking performance, properly caching your network data is one of the most fundamental performance wins that you can create. At its core, reading data from your device will always be faster than reading the same data from your network connection. And if you consider that that piece of data will be used multiple times, it makes a lot of sense to fetch it from the network and then store it on the device so that future requests don't have to re-download the file. But a slight problem here. You see, by default, caching of HTTP responses is disabled for Android applications. Pretty much everything you're requesting in your app right now is just dropped on the floor after it's been fetched. Turning caching on means using the HTTP response cache class, which allows you to define a location on the device's physical file storage as well as a max size for the cache to be. Now, once enabled, all HTTP responses for your application will be cached on the file system. And yes, this does apply to APIs like a URL connection and HTTP URL connections and all the other fancy code snippets that you copy-paste from Stack Overflow examples. And don't forget that this also applies to any HTTP requests made from libraries that you've bundled into your application. Now, it's worth pointing out that with HTTP response cache, data is evicted from the device in two ways. Number one, if the cache fills up, then the system will delete the oldest unused files to make room for the new ones. And number two, files will be removed according to their cache control header information included with the server response. See, for HTTP 1.1 standards, the server will pass a flag down with your requested data that hints to the device how long the information should be cached for. So if the server says something like cache it for 3 days, then the device will keep the file around for 3 days before evicting it. Or if the server says don't cache, well, the file won't be cached on the device at all. Basically, HTTP response cache puts all the control of how to cache content in the hands of the server, assuming that it knows best what types of data you're requesting and how the device should use it, which is completely fine for simple networking situations, or if you somehow control the server and have the ability to set caching explicitly for each data type. But beyond that, you can get into some really big trouble, especially if you don't control the server. For instance, what if the server never sets caching duration and nothing ever gets cached on your device? Or what if the caching values are in conflict with the physical resources of the device, like misestimating how much free space there is to cache? Or what if your client is trying to be adaptive to the needs of high latency environments and actually tries to modify the way it's caching due to those environments, but the server won't let it because it assumes you're on a 4G network? Basically, any of these advanced situations requires you to punt on HTTP response cache and instead brew your own caching solution, which includes two things. Number one, writing your own manager to cache and fetch resources from disk on demand. And number two, creating your own caching policy based on the type of data and the state of the device itself. Now, writing your own disk cache can be a bit of a pain. So unless you need something custom, it's probably a better idea to steal the disklru cache.java implementation from the Android source and repurpose it for your needs. One of our sample code packages has already done that for you if you're willing to take a look. Now, probably more complex is defining a policy for what types of caching to do for what types of assets you're grabbing from the server. See, thumbnails need to be cached less often than high-resolution images, and other things like server pings probably shouldn't be cached at all. And you might want to keep around server responses that describe UI data for a much longer duration. The truth is that this is all exceptionally complex, and thankfully, there's libraries out there to help make it easier. Grabbing the Volley or OKHTTP libraries will put you on a good start to a more stable networking implementation, although you have to fiddle with the source code a little bit to get it to call your custom caching logic. And by the way, the image library Picasso comes built in with custom image cache management on your behalf. Now, if you're not sure how caching or lack thereof is impacting your application, make sure you check out the Networking Monitor tool inside of Android Studio. It offers a nice visual representation of the types of inbound and outbound requests that are happening. If you're seeing some requests for content occur that should be cached instead, it might be a good sign that you should be digging deeper, which is why I like to use AT&T's ARO tool. It basically lets you do exactly that, dig deeper with each network request, even checking out what types of network header data has been sent to the device. But caching your data is just the start. That's why you need to check out the rest of the Android Performance Patterns content, and don't forget to join our Google+ community for tips from other developers. So keep calm, profile your code, and always remember, perf matters.